Welcome to Organic Chemistry, Lesson 5. Now we're going to talk about alkyl halides, which is also called haloalkanes. They are hydrocarbons where one hydrogen atom has been replaced by a halogen atom. Your halogens are fluorine, chlorine, bromine, and iodine. The general formula is CnH2n plus 1x. The X is the symbol we use for a halogen. The halogen atom is called a substituent. A substituent is an atom or group of atoms bonded to a carbon chain like an alkyl group or a halogen. So as for previously, we had a carbon chain with alkyl groups as substituents. Now we're going to have an alkane chain with halogen substituents, and they we call haloalkanes or alkyl halides. Uses of alkyl halides are in fire extinguishers, aerosol propellants, refrigeration, and dry cleaning. How to name haloalkanes? It is still alkanes, so the end of the name will still end on -ane. And then you determine your base name as usual, prop for 3 carbons for example, and then you can have either alkyl substituents and or halogen substituents. If it is a chlorine substituent, you call it chloro. If it is a bromine substituent, you call it bromo. If it's an iodine substituent, you call it iodo. Example 1. Give the IUPAC name of this molecule. Now the first thing you should notice is this is not the structural formula, it is the condensed structural formula. Therefore, it's difficult to number your carbons and see what's going on in the molecule. So the first step is to draw the structural formula of this compound. CH2, CH2 with a bromine bonded to that carbon. Then you move on to the next CH2 group. There it is, CH2. And then you have a CH3 group at the end of the chain, CH3. Now you have to identify the functional group. As you can see, it is an alkane, but with a halogen, therefore haloalkane. Number your carbons. You can either number from the left-hand side, 1, 2, 3, or from the right-hand side, 1, 2, 3. But now you have to decide which color number system is the correct one. Your substituents should always be at the lowest possible carbon number. So, the purple numbers are the correct set because here the bromine atom is at carbon 1. As for the green set numbers, the bromine atom is at carbon 3. So moving on with the purple set of numbers, you have 1 bromo propane. 1 bromo because there's a bromine at carbon 1, propane because it's 1, 2, 3 carbons. Example 2. Draw the structural and condensed structural formula for 2-iodo 3-methyl pentane. Again, the first step is to draw your 5 carbons. Why 5? Because pent means 5. So here are your 5 carbons. Now you insert your substituents. 2-iodo, which means at carbon 2 there should be a iodine atom. And then 3-methyl. Therefore at carbon 3 there should be a methyl substituent. And now for the condensed structural formula. The first carbon is CH3. CH3. The next carbon is bonded to a hydrogen and an iodine. Here's the iodine atom in brackets to show that it's together with this carbon. Your next carbon has got a CH3 and a hydrogen. Hydrogen, CH3. Then you have a CH2 group followed by a CH3 group. CH2, CH3. Example 3. Give the IUPAC name of this molecule. Again, this is a condensed structural formula. You cannot number your carbons properly and see what's going on in the molecule. Therefore, the first step is to redraw it as a structural formula. There you go. So, the first step is to identify the functional group. This is an alkane with halogen atoms, therefore haloalkane. Now you have to find your longest carbon chain, which is the linear one, and then number your carbons. Again, you can have two possible sets of numbers. The green numbers start at the left-hand side, the purple numbers start at the right-hand side. Now let's see which set is the correct one. At carbon 1, we have, for the green set, a fluorine, and at carbon 2, 2 chlorine atoms. For the purple set of numbers, we have a chlorine at carbon 3, 2 chlorines, and at carbon 4, a fluorine. Now your substituents should always be at the lowest possible carbon number. Therefore, the green set of numbers are correct because the fluorine and the 2 chlorine atoms are then at carbon 1 and 2, which is lower than 3 and 4. So the name then, 2,2-dichloro, because there's 2 chlorine atoms at carbon 2, 1-fluoro-butane, because there's 4 carbons. Now you should ask me, why is the 2,2-dichloro in front of the 1-fluoro? Why is it first and then fluoro second? And the reason for that is alphabetical order. Your substituents should always be in the name according to alphabetical order. C is before F. You ignore the di part and you look at the C for chloro and the F for fluoro. And then you arrange it that way for your name. But that plays no role in the numbering system. Thank you.